olayları içeren bir bölüm olacak. Bu bölüm için son derece etkileyici bir yalıtım uzmanını huzurlarınıza davet edeceğim. Soyadını benim için söylemek kolay olmayacak ama Doktor Stefan Ulsch. Stefan, Doğu Elastomers Bina ve İnşaat Membranları Global Teknoloji Bölümü lideri. Stefan, İsviçre merkezli Dow Elastomers Yapı ve İnşaat Membranları Global Teknoloji'nin teknoloji bölüm lideri. Bu mevkide Stefan, yeni gelişmeler ve projeler için teknik destek ve müşteri hizmetlerinin koordineli çalışmasından sorumlu. Yapı ve inşaat membranları, polimer işleme ve formülasyon geliştirme konularında 20 yıldan fazla deneyime sahip olan, çatı ve su yalıtım sektöründe de dünyaca tanınan bir uzman. Stefan 1991 yılında Tayvan katı inşaat ve yapı profillerinde klorlanmış polietilen servis mühendisi olarak dava katılmıştır. 1994 yılında Stefan Huber and Sanher'den ayrılıp TPO çatı formülasyonu geliştirme ve TPO çatılar için direkt ekstrüzasyon tesisi kurma işinde çalışmıştır. 1996 yılından itibaren Stefan, birleşme, polimer işleme, tel ve kablo alanında çeşitli global projelerde uzun yıllar çalışmıştır. 2001 yılında bugünkü ismi Sika Skoflex olan Stefan Huber and Sanher çatı ve yalıtım bölümünde teknik direktör olarak görev almıştır. Stefan 2005 yılında özel plastik ve elastomer geliştirme mühendisi olarak Dow Avrupa'ya geri dönmüştür. 2007 yılından itibaren de şu anda yürüttüğü görevi yürütmektedir. Stefan, Almanya Stuttgart Üniversitesi'nde PhD, doktora ve master derecelerine sahiptir. Aynı zamanda İsviçre Lausanne Business School'da yüksek lisans yapmıştır. Değerli konuklar, biraz önceki nezaketinizi Sayın Doktor Stefan Ulsch'ta göstereceğinize de inanıyorum. And I'm inviting Dr. Stefan Ulsch to take the stage to talk about the new technologies. Please, sir.
Thank you, Salim, for the friendly introduction. I hope everybody can hear me. Oops. And in my presentation, I will explain the value of TPOs, thermoplastic olefins, and why these polymers are the future in roofing and waterproofing. And today I will go along following structure. I will start with applications, current applications for waterproofing membranes, and why TPO is the winning material. I show the material and market trends, and then in the main part, oh yeah, that would be even better. Or I can hold it. Is it okay like this? I'm too energetic, I'm sorry. And then in the main part, I will explain why TPO membranes. I will go from the design and system options of these materials. I will explain manufacturing, installation and end use step by step. And today I will emphasize especially the environmental aspects. Green and so on has been mentioned several times, and along the value chain and the life cycle of the products, I will explain why TPO are the materials of the future. First of all, applications of TPO roofing membranes. When we talk membranes, we usually talk structures from about 1 to 2 millimeter thickness, scrim reinforced, and we put that on the roof. In the case of an unballasted roof, there are several properties which have to be observed. UV resistance, very high loadings of snow, rain, climate conditions. They have to be bright to have heat reflectance. So it's a full set of different properties that have to fulfilled for an unballasted roof. And today, as also Multiplan pointed out already, these roofs are often used to add additional functionalities. You integrate thermosolar, photovoltaic systems or whatever. You do more with the roofs than it was done in the past. When you go for ballasted roofs like green roofs or gravel covered roofs, you have to fulfill other properties, other requirements. Now hydrolysis resistance, root resistance comes to play, parameters like this. For all these applications, TPOs offer the best value and the best properties. When you abandon roofing and you go for further waterproofing, then you start talking about tunnel liners. And for example, for tunnel liners, which are very thick membranes very often, you need a very good flexibility, you need a very good reliable welding, and you need a welding without fumes, without toxic emissions. Can be very nicely fulfilled with TPO. Or if you go for water reservoirs, geomembranes, landfill liners, again, olefins, TPOs offer the best balance as they have best pressure resistance, good welding, and for example, drinking water approvals are very easy to obtain. Let's take a look at the market for Europe, and here I just show single-ply roofing, but it gives the overall trends. Recovering from the economic crisis in 2008, the market in Europe in 2010 was rated at 360 million square meters installed. As it is recovering, we face a 10% growth. 4 materials are dominant. It's still the EPDM, PVC, largest part is bitumen with around 75%, as you see here by the bubble, and TPO. But more interesting than the market share is the growth rate. And you see EPDM is losing share, PVC is losing share, bitumen has been stable last year, but this will not pertain. It was stable because it's largely used for refurbishment, for repair, but on the long run, with new buildings coming up, it will lose share too. So the winning material overall is the TPO. And why is TPO the fastest growing material? In these industries, which are cost sensitive, there is in any case one overall parameter that's decisive. Optimize system costs. Along the value chain from design to manufacturing to installation to service life, everybody wants to get the best value in waterproofing. Now as the environmental footprint, green aspects come to play. For the presentation of today, I outline especially aspects in combination with green roofs and in green aspects as mentioned here with the red colors. And I will discuss it step by step. Concerning environmental footprint, green aspects, TPO offers an excellent property balance. That is the major reason why these materials are growing so fast. Let's start with the system, with the design that are possible for membranes and for waterproofing systems from TPO. There are many design options. In principle, you have the TPO top and bottom layers, but the layers you can combine with co-extruded top layers with functional surfaces. You can coat them, you can laminate film to them. There are very open possibilities to make differentiated products. In the middle, you can add glass fleeces as a reinforcement to reduce shrinkage, to reduce creep, but also to improve fire resistance. Or you can add scrims and fabrics in the middle, polyester, for example, glass fabrics and so on. So you get a very sturdy, strong material to cope with wind loads. And at the bottom you can combine with fleece backing, with substrates for adhesion. So there are all kinds of options to design waterproofing materials. When you take all these options and you apply them to the different applications that you see for waterproofing, you come up with such a slide or such a picture. Again, you see the applications for single-ply flat roofing, mechanically fixed or adhered roofing. You have the green roof aspects, but you can take the same materials also for pitched roofing, for breathable membranes, all kinds of things. You can design formulations and polymers to different applications. But you can also move into subsoil waterproofing, pool and tank liners with drinking water approvals. You can go to parapet sealants, expansion joints. What I want to say, with TPOs, you have the possibility to make a toolbox to develop materials for any waterproofing application. And these materials can be combined and heat welded together, so you have from one base formulation a manifold possibility to develop systems, cost-effective systems, green systems. Now I move away from the design and from the system into the next step, which is the manufacturing of a TPO membrane. And overall, TPOs with the most modern manufacturing technologies stand for low energy production. You see an outline of the concept here. In the so-called direct extrusion, you feed the polymers and the fillers all in one compounder, heat them up, melt them, and then you shape the membrane right away afterwards. Energy efficient in this context means you only have to add the energy for once melting and shaping. There's no compounding need, no separate steps, and in combination with Dow elastomers, you have a very favorable melting performance. So, what do we have with our Dow TPO solutions? Compounding and shaping in one step. Fast product change can be done. If you want to modify your formulation, you can do it by the loss weight feeders, and you have most flexible design options that you saw before. When I want to point out multi-plants production, and I stole a photograph from your line, it is according to latest technology. Latest technology also stands for good homogenization for high quality products. And as mentioned by Nazim Bey, it's excellent energy efficiency, no emissions, and recycling of production waste can be done in line or whatever. It's a very ecological production. Now leaving the production aspect, another one. Pierre already showed this slide and he didn't want to excurse too much. This is Dow product mix, and coming from the product mix, coming from the polyethylene side or the polypropylene side, in combination with the production process, with the direct extrusion, you can tailor online very quickly your formulation. So from one set of formulations, you can run roofing membranes, water management membranes, tunnel liners, systems. You can swap easily and you can build up a kind of a toolbox. And to make a little bit of an advertisement for Dow, Dow in polyethylene and polypropylene has a very, very broad product mix, very versatile product mix. That's all I make as advertisement today. Now we move from the production to the third step of the life cycle of a membrane, which is the installation. The first point in installation is of course the logistics to get the material on site, and Nazim has shown this very nice slide with the trucks on it and the energy consumption and these kind of things. If you have low weight TPO membranes which provide a high longevity, you have a green aspect as there are low transport costs involved. Now when you have the membrane on site, the next step is the build-up of the roof. And there is one very, very decisive factor, which is the welding performance. You need to have fast and reliable welding in hot climate, in sunshine, in rain, in snow. The moment you have to pre-clean membranes, if you have problems in welding, if you have things, your time runs out, you get problems with your contractor crew, you get problems with your costs. So welding is a key issue with TPO membranes, and Dow olefins offer the best welding. Another aspect is of course the flexibility and ease of handling. I will explain more. And as Nazim also mentioned, I guess, if you have long rolls stretched over a long surface with a high longevity, you need less welding. So it's faster to contract them, faster to install. Overall, easy installation is one of the key factors in terms of costs, but also in terms of energy and time usage. When I explain the welding as a key factor, I want to show you only one technical diagram today, the so-called welding window. This is an industrial proven method to decide on the welding performance of a polymer. This welding window was not run by Dow or Multiplan, it was run by Leicester Process Technologies, the leading company for welding equipment. What they did run as function of the temperature, of the setting of the welding device and the welding speed, they determined the so-called welding window. When you see an old-fashioned TPO, it has a relatively narrow window, relatively narrow welding conditions. When you take the welding window of Multiplan TPOs, you see a very broad welding window at a very broad range of possible welding speeds at relatively low energy input. So again, we have a low energy, high welding speed, an environmental aspect. Overall, such a membrane is simple and forgiving in installation. And besides, as it is halogen free, there are no fumes, no degradation products, no oligomers coming out. Also an environmental aspect, especially for tunnel liners. I talked about flexibility. You can imagine if your membrane is not flexible, it's bulky to handle. If it doesn't roll back on the roof, it's bulky to install, you have to put weight on it. The contractor crew is easily overwhelmed with work or doesn't like the material. You see on this slide the results from a very simple test. I took some standard TPOs and I took TPOs according to latest Dow technology, and you see a very, very favorable aspect of flexibility in combination with Multiplan TPO. Now I move away from the installation into the end use, the service life of the membrane. The service life is also very important because if a membrane, like many TPOs from overseas that are just holding 10 to 15 years and you have to replace soon, it's not good. Today, modern formulated and state-of-the-art TPOs from modern polymers can reach up to 25 years of longevity in unballasted roofing applications. Depending on the roof design, ballasted roofs, this longevity can be reduced. In ballasted roofs, there's a lot of hydrolysis, a lot of dirt pickup, so that reduces the longevity. While, for example, in green roofs, the longevity can be expanded because the heat load, the temperature on the roof, is lower for the membrane. But overall, an unballasted roof, nicely formulated, can reach a TPO expectancy of 25 years today. TPO from Dow elastomers, what we have done in-house. We have done very thorough lab scale and outdoor testing. We are working for our formulations with the leading suppliers of additives, for flame retardants, for stabilizers. So we have a very high confidence in all our data and all our products. In terms of longevity, a high longevity also means energy saving. The material doesn't have to replace and doesn't need to have maintenance. Then I move over to the other aspect that's often talked about. It's cool roofs. Nazim Bey also showed a slide on that one. When you move, and it's swapping over, especially from the US, these aspects of cool islands, heat islands in the cities and so on. If you move from a black bitumen membrane to a high reflecting white membrane, the rooftop temperature in southern climates can be 45 degrees C lower. If you have a weak roof insulation and a weak roof design in combination with high expectations on air conditioning, this difference can make up to 30% more energy usage for air conditioning, or vice versa, less energy usage if your roof is white. In the term of city areas, if all the roofs are black, you feel it in summer how the heat of the ambient air is very hot and inconvenient. The moment you have the white roofs, the ambient air temperature comes down, you have a much nicer climate in the summer, and actually also less thunderstorms in summer in urban areas. That's proven. So with TPOs, you can color to any color. TPOs, by the nature of being olefins, have a low dirt pickup, or if they have picked up dirt from the ambient, you can easily clean them and wash them again. You can combine the roofs with reflective top layers or coatings, that is possible. I think it's not recommended to begin with. Maybe after a couple of years of service, somebody would like to think about something like this. In combination with thermosolar photovoltaic applications, this effect of heat reflectance and reflectivity comes to play. In addition, can be used to have higher efficiency of photovoltaic systems or heating systems. Another aspect I want to mention with TPO roofing, because it's often discussed and there are several spectra outside. It's fire resistance and fire behavior. In general, in Europe, according to European system standards, TPOs from Dow elastomers can pass very well with very flexible solutions. So, highest European fire resistance standards mean a safe roof and mean a safe fire behavior. Dow has developed several packages for halogen-free TPO solutions that pass the relevant standards, like here the German one, the French one. In combination with halogen-free materials, there is never a toxic fume and there is no dark smoke. And the dark smoke is for other materials a big problem, as that hinders and is an obstacle for the fire crews. Again, excellent welding as shown, flexibility as shown, and high fire resistance in one product. That is done by modern state-of-the-art polymers. Environmental aspects. Advantages of TPO. I mentioned already there's a low energy use in production and installation for a modern TPO according to modern processing technology. TPOs do not contain halogens or heavy metals. There are no antimicrobials needed. Modern TPOs have no oligomers or a very low level of oligomers. No plasticizers are needed, no plasticizer migration. And there are no curing agents, like for example in thermoset applications like EPDM. What that means, we have no migration of additives, and no migration means no contamination outside of the roof, but also means a high longevity because the ingredients and the active substances stay active in the membrane. With TPO, drinking water approvals are easily achieved. It's just you have to register for the right things, you have to disclose your formulations, and you have to get some tests passed at the accredited institutes or whatever, depending on the application. But in principle, olefins are very green, environmental healthy materials. Recyclability is given for all of the TPOs along the value chain. Can be done in the manufacturing, can be done during the contracting, and can also be done after the life cycle. If a roof is old after 20-25 years and you don't want to go for recycling, you can still take it and put it into incineration plants. You can burn it without release of halogens. It actually can be used as a source of energy in the incineration plant. With the last slide, I want to show and emphasize the advantages of modern TPOs, like Multiplan is producing, and I emphasize them along the alternative materials that you find on the market, and I explain manufacturing. The technology is absolute state-of-the-art, which gives a high-quality membrane. The installation, the welding is absolute top. It is fast and simple, high flexibility, so it can be done by relatively untrained contractor crews in a fast way. And over the service life, you saw longevity is good. Energy saving can be done to any energy saving level required. Fire behavior and environmental aspects. Overall, TPOs are the future, and overall, TPOs from latest stage polymers can be tailored to any waterproofing application. Thank you very much for your attention.
Thank you, Stefan. It was a great presentation.